Alright, so welcome back in this video. Now, in this video under image circular functions, you are going to find function values using the definition of the trigonometric functions. But before we start, I would like to answer somebody's question. I would like to answer somebody's question on how do we find, says how do we find, let's say, cosec inverse of -3. It's just simple, alright? It's just simple. First of all, know that the reciprocal of sine is cosec, alright? So this one is the same as 1 over sine inverse of -3. And the question is, can you find sine inverse of -3? If yes, then you can get that for cosec. It's just simple. Then you can get that for cosec. Alright. Another concept is also that this one is the same as writing it as sine inverse of 1 over -3. This one too is the same as that. Okay, you can write cosec inverse of -3 as this or as that, and you get the same answer. Very good. So you just, in case you be confused, just go straight to the point. You ignore this and take for that. Very good. So for instance, if you have cos, let's say cos -3.5 cos, this one will be undefined. Let me pick 0.356. This one will just be tan inverse, sorry, cos inverse. So this one will be tan inverse of -1 over 0.356. So that's how you punch it on the calculator and you're going to get your answer. So simply for sine inverse, for sec inverse of s is the same as cos inverse of 1 over x. And for cos inverse of s is the same as tan inverse of 1 over s. Lastly, for cosec inverse of s, no matter the angle length, is the same as sine inverse of 1 over x. Very good. So we can now proceed to what we have for today. Very good. So that is that. It's not anything difficult. Okay, so let's move on to finding function values using definition of the trigonometric function. So let's go for our first example. Evaluate each expression. Evaluate each expression without using a calculator. Without using a calculator. And sometimes even if you use calculator, it will not give you the exact value. Alright, so the first one is sine. With this, I'll take my time to explain for you to understand it well because it's very, very important. Very good. Then the second one is tan cos inverse of -5 over 30. Very good. So now let's move on. So looking at the first one, A. Here, we are going to let theta, please watch. Here, we are going to let theta be equal to tan inverse of 3 over 2. Now, don't forget that the whole of the tan inverse of 3 over 2 is the argument for what? Sine. Is the argument for sine. So, when we let theta to be equal to, that is the argument for sine, to be equal to tan inverse of 3 over 2. Don't forget that now what we have will be sine theta, to be sine theta, because the argument is now what? Theta. Very good. Very good. Very good. So then here we can take tan of both sides. And when you take tan of both sides, tan theta tan of tan inverse of 3 over 2. Most people don't know this. Okay? So here we get tan theta to be equal to, and this we won't do this, okay? Because tan times tan inverse, or sine times tan inverse, or cos times cos inverse, it won't do it, leaving the what? The argument, and that is the concept. More than time when we ask you to find theta, then you write theta is equal to tan inverse of 3 over 2, but the person don't know why he or she is doing that. That's where it's coming from. It won't do it. Very good. So now, the inverse tangent function yields values only in what? In the quadrant. Which quadrant do you think this one will be? Alright, very good. So, the inverse tangent function yields values only in quadrant 1 and quadrant 4. Because we know that here tan is positive. Tan is positive here, and tan is also positive here. Okay? I said quadrant. Yeah. Tan is positive here, and tan is positive here. So we can see that the inverse tangent function yields values only in quadrant 1 and quadrant what? 3. So, since 3 over 2 is positive, theta is in quadrant 1. Since 3 over 2 is positive, theta will be in quadrant 1. Alright? Very good. Because we can't be in both what? Quadrants. We can't be in both quadrants. So we take it to be that we are in quadrant 1, where all the trigonometric functions are positive. Very good. So the next thing to do after this is to go and sketch it, knowing that you are working in quadrant 1. Hope you are watching. Very good. And the argument is theta. So tan theta is y over x. This means that y will be equal to 2, x will be equal to 3. Sorry, y will be equal to 3, x will be equal to 2. Then let's go and find the y. Please, I would like you to go and do that yourself, because with that one you will do it. That is x squared plus y squared equal to r squared. When you do that, you get square root of 30. Then after getting the radius to be square root of 30, then we can now go and find whatever we want to find. Because now you can see that, please watch. We let theta to be equal to the inside. So now what is left here is sin theta. And from this, we have tan theta to be equal to 3 over 2. So here, we can get tan theta to be 3 over 2. So what is therefore going to be sin theta? What is therefore going to be sin theta then? So sin theta is going to be y over r, which is 3 over square root of 30. That is why there is a need, or that is why there will be a need for you to go and find for the radius. I hope it's clear. Very good. So now we can now conclude. Let me write it here. Okay, let me conclude it. So since theta here is tan inverse of 3 over 2, we can now conclude that sine of tan inverse of 3 over 2 is equal to, let's rationalize this. 3 root 13 over 13. So we get 3 root 13 over 13. Very good. So that's going to be the final result for that. I hope it's not difficult. Very good. I would like you to try the second one on your own. Follow the same steps and go your way. But be careful the quadrant we are working with. Be careful with the quadrant you are working with. Knowing the quadrant is very, very, very important. Alright, so let's look at the B. Now the B part is that object is negative 5 over 30. Very good. So here we let theta to be equal to cos inverse of negative 5 over 30. Then we take cos on both sides, so we get cos theta to be equal to negative 5 over 30. I hope that is clear. Very good. Then now we know that cos is negative. Here we are going to identify the quadrant. Now, since cos inverse for a negative value of s is in quadrant, so where will this quadrant be? I don't want to tell you, just straightforward. Cos is negative. All students take calculus. So you can see that this is negative, whether this is positive here and it's positive here. Okay, so this is negative whether here or here. It's whether here or here. That is where it's going to be what? Negative. Very good. But with this, we conclude that it's going to be it's going to be negative in the second quadrant. So with this, we are working in the second quadrant. Alright. So knowing that you are working in the second quadrant, then you can now go and sketch. So we are working in the second quadrant. Then we can now go and sketch. This is s, which is negative 5. Then this is 13. The r is 13. So when you go for this, go for it. You get 4. Very good. So we now come back to write tan theta. So we see what tan theta is going to give us. And after that, I will tell you something. So let's see what tan theta is going to give us. So tan theta is going to be, that is s over y. So that is going to be negative. Tan theta is, y. So that's going to be 12 over 5. because of the negative, then it will come. Very good. So we get negative 4/5. Now you can see that it can't be in the third quadrant because we realize that whether it's in the second quadrant or the third quadrant. So you can realize that it can't be in the second quadrant since the negative will be affecting the s. Okay, very good. And for the y, it's positive. We have y to be positive because we are working in the second quadrant. So it can't be in the third quadrant. So tan is going to be negative. Cos is going to be negative. Very good. So therefore, we conclude that tan cos inverse of negative 5/30 is going to be negative 12/5. Okay, let's move to the next question. Let's first go for the first one. Okay, very good. Let me start from here. So from the first one, we have cos arctan square root of 3 plus arc sine 1/3. You know that this is the same as cos tan inverse of square root of 3 plus sine inverse of 1/3. Very good. So now, here, we are going to link this to what we know already. And that is, we are going to let A to be equal to tan inverse of square root of 3. Then B to be equal to sine inverse of 1/3. Please, I hope you are watching. Now, before everything, I would like us to go and look for these values. Let's go and look for these values. Alright. So, for us to go and look for these values, or before that, let me see, okay. Let's continue after that. We will go and look for that values. Now, let's do the substitution. Because whatever you like, no matter what, you go for the value. So you can go for it before or after. It's still the same thing. So here, this is A plus this is B. So we can relate this one to cos A, cos B, minus sin A, sin B. Very good. So now, having this, then what's the next thing to do? The next thing to do is to do the substitution back. So cos tan inverse of square root of 3 plus sine inverse of 1/3 is going to be cos A, and A is what? Tan inverse of square root of 3. You see that the space is too small. Wow. Okay, let's manage. So, let me bring that down here. So this will be equal to cos A, and the A is tan inverse of square root of 3 times cos B, and the B is sine inverse of 1/3 minus sine A, and the A is tan inverse of square root of 3. Beautiful. Sine B, and the B is sine inverse of 1/3. So these are the values that we are to go for. The value for cos of tan inverse of the square root of 3, cos of sine inverse of 1 over 3, is it negative? No, yes, 1 over 3 is not negative. Okay. So that's sine inverse. Okay, okay, it's not negative, but the sine inverse of 1 over 3. Then that. So let's go for those values. Very good. Then after that, we just come and do substitution. And you know how to get this. You know how to get this, not to get that, not to get that. So it's not anything difficult. Very good. So now let's move on. And don't forget that they are all going to be in the first quadrant. Because well, okay. Because this one is tan and it is the same as 1 square root of 3 over 1 and it is positive. The argument here also is what? Positive. So it's going to be in the first quadrant. Going to be in the first quadrant. Please, I would like to bring this part. So let's go and look for cos tan inverse of square root of 3. So we let theta to be equal to tan inverse of square root of 3. Okay. Now it's without using calculator, so you can use calculator to point this. So this is the same as over 1. So this is the same as tan theta, that's taking tan on both sides. Tan theta is equal to square root of 3 over 1. Then you go and sketch it. It will be in the first quadrant. So that is y over s. So here is square root of 3 over s, and here is 1. So you go for this. So you go for this yourself. And when you do that, you get 2. After getting the 2, you have to know where the 2 is coming from. This square plus this square is equal to r squared. And you find for r. Very good. Now, after that, then you go for cos theta. And that's going to be s over r. So that is half. Therefore, we conclude that cos tan inverse of square root of 3 will be equal to half. Then you come to this side, you write half times. I hope it's clear. Very good. So half times. Now we go for this. Since the argument, since here is square root of 3, here is 1 over 3, you cannot use the same graph for it. So you need to go for another one. Please, I would like to claim the same part. Make sure you write that. Are you done? Very good. Now this one too, you can see the okay, that is let me write. That is cos sine inverse of 1 over 3. Now the argument, this one, the argument for sine inverse is positive. So this will be in the first quadrant. But we let theta to be equal to sine inverse of 1 over 3. So sine theta is 1 over 3. Then we sketch first quadrant. S over R. That is S over R. Then we go for this. And when you do that, okay. Let me mistake somewhere. Let me check. Okay, there's no mistake. So now, the square root of 3 cos of Okay. So here, that's where the mistake is coming from. Sine is y over sine is y over r, not s over r. That is opposite over the hypotenuse. So y here will be 1 and the r here will be 3. Very good. So we now go for, very good. So this is the B. This is the B part. So we now go for this. And that is 3 square plus 1 square. Sorry. S square plus 1 square is equal to 3 square. And you go for that. And you're going to get 2 square root of 2. When you do that, you get 2 square root of 2. Then you come back. What is cos theta? Because it's called, the whole of this is theta. So that is going to be S over R. So 2 over 3. Therefore, we conclude that cos of sine inverse of 1 over 3 is going to give us 2 square root of 2 over 3. So that is for this part. Then we move on to this part. So write that and let me print it. You can pause the video and go for the rest on your own. Okay. So what is this one two going to give you? We let theta to be equal to tan inverse of square root of 3. So therefore, tan theta is equal to, in fact, you can use that diagram. The one you used to do this. The first diagram, we can use it here. Okay, we can use that first diagram here. How we can see that? We can use that here. Because instead of finding cos theta, I'm forgetting the diagram. Let's do the diagram. Because it's the same diagram that you try to do this, you sketch. And that diagram, we have here to be 2, here to be square root of 3, then here is 1. So that's for this diagram. Very good. So you see, cos theta will be 1 over r, 1 over 2. That is that. So let's use that to find sine. So we can use that to do this. So for sine theta, since that we know that for sine theta, we get y over r, which is this. So that will be square root of 2. That will be square root of 3. Hey, exactly. Square root of 3 over 2. So here, square root of 3 over 2 times. We can use the other diagram also to get that. That is the second diagram. And that one we had it like this. Here is 3, here is 1. 2 square root of 2. Okay, so that one too. Here we are looking for sine. No more cos. Wherever we had this. So cos theta, sorry. Sine theta is y over r, which is 1 over 3. Very good. So that is what you are going to get for that 1 over 3. Then after that, you just use your calculator to plug this and see what you're going to get. So finally we get this and this, you get 2 over 6 minus 3 over 6. Alright, very good. So that's what you're going to get. And when you combine all, you get 2 root 2 minus 3 all this over 6. So this is going to be the exact value. So even if you use your calculator to punch it, you will not get the exact value. So this is going to be the exact value for the question A. So let's now move on to the B. Alright, so the B part solution, this is the same as tan 2, then this one will be sine inverse of 2 over 5. Very good. So that is what we have. Now please here, oh wow, I love this question. Please here, be careful. Know that the whole of this is an argument. Is that no? Is that so? The whole of this is an argument. So the 2 here is a constant. So it's a double angle. Hope you can see that. Simply it's a double angle. Very good. So when we let theta, not always theta, you can use B, C, and all that. So, but we are used to using theta. So let theta to be equal to sine inverse of 2 over. Okay. So theta will be equal to, okay, sine inverse of 2 over 5. This means that when you do the substitution back, you get tan 2 theta. I hope you can see that. You are going to get tan 2 theta. And tan 2 theta is a double angle. And the formula for this double angle is going to give you 2 tan theta over 1 minus tan square theta. This is the formula for this one, double angle. I like this. So do you know what we need to go for? You don't worry. We know that with this, if we are going to get sine theta over, that is when you take sine on both sides here. When you take sine on both sides here, you get sine theta to be equal to 2 over 5. You get sine theta to be equal to 2 over 5. Which is the same as y over r. So when you take it, and with this, it will be in the first order because it is positive. When you take it here, here is 5, y is 2. So we go and look for this. Okay, so for that one, I leave it to you to do. When you do, you get square root of 21. When you get that place to the square root of 21, then what is this? Okay, that's that. Okay, so now we can go for here. Since to solve this, you know, writing this form is the same as this one. I hope it's clear. Very good. Let me bring the argument of theta. So for us to get this, which is a double angle, we need to know tan theta. We need to know tan theta. And here we can get tan theta to be equal to, that is y over x. And that is 2 over square root of 21. When you rationalize, you can rationalize this. And when you rationalize, you are going to get square root of 21 over square root of 21. So this will give you 2 square root of 21 over 21. That is the rationalized form. So by substitution, the double angle, which is the same as this, is 2 times 2 square root of 21 over 21. The whole of this 1 minus 2 times square root of 21 over 21 squared. Alright, so very good. Then we end up getting our final answer to be 4 square root of 21 over 17. Very good. So that becomes our final results for that. Oh, hope it's interesting. So you cannot conclude, therefore, this is equal to 4 square root of 21 over 17. So this is a double angle. Thank you. See you in the next video. And in the next video, we are going to talk about Or should I solve this question? Okay, let me leave this one for you to do. Let me leave this one for you to do. You are to, let me write it on the board. All right. I would like you to try on this. Okay, thank you. See you in the next video. The next video, we are going to talk about. All right. In the next video, we are going to talk about solving trigonometric equations. Okay, we are going to do the one involved with the function and the one involved with inverse circular functions. Then after that, we move on to the last part, and that is sine root and cosine. Then we proceed for everything. Very good. For now, know that you are not. Make sure you try on this. It's not difficult. We have solved similar of them before. All right. Thank you. See you.